PSK 98, what I call return of the ready. Why? Because effectively it's two very close space frequencies, conversational, but probably one of the most popular digital modes currently, or for even the last decade on the bands. It was specifically designed to allow conversations, right? Yeah, as we saw with APRS, it's a little burst. You're not really going to get chatting away that way. Packet had pretty much died at its death in the late 80s in terms of people communicating that way. So PSK stands for phase shift keying. So what it actually does is it uses two phases, 180 degrees out of phase, and the transition between 1 and 0 is done using that phase shift. There are a great number of flavors, the most popular being binary phase shift keying, 31 for 31 baud. It's actually also 31 hertz wide. With operator discipline, we'll talk about that a little bit later, you can get 20 PSK conversations in one sideband channel. And that's probably the popularity of the mode. Tune up one frequency and watch 20 conversations scroll across the screen. So it is a low power mode. You don't need to be running a huge amount of power. And therefore, if you're in compromised antenna locations and those sorts of things, it's one of those nice modes to be playing with. Resultant operating speed is somewhere between 30 and 50 words a minute. I've said 50 there. User Vericode, it was actually custom designed, a bit like Morse or CW in some ways, in that the most commonly used letters generally are shorter and quicker to transmit. The Vericode for PSK was specifically taken out of the English language, and so yeah, it's done in lowercase, and the most common letters are the shortest to transmit, and that gets some efficiencies in terms of getting that speed up. There is no error correction in the standard binary phase shift keying, although when you go quadrature, so another pair of frequencies, it does actually have error correction built in. Various speeds, most common being 31. There is also 63 and 125 to get those even higher throughputs happening. But I did say user discipline is required to ensure that the driving signals are kept down. If you over-modulate, then you'll get intermodulation distortion, especially in the second order harmonic. And you'll see them on the waterfalls, and that's what the signal looks like. It's just generally a little peak, and if you see it on a waterfall, it'll be just two very fine bars, which is actually what's in the background there, and that's a standard 2.3 kilohertz with, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, about 12 conversations happening there. What's it sound like? Because the trick is to try and learn these by ear, so you pick them up on the band. Where will you find it? Usually just below ready. So if you hear some ready and you wind down a bit, you'll tend to find the PSK operators sitting just under that. Digital slow scan. In about 2000, in the early 2000s, 2002, we had radio mondial, digital radio mondial come in the commercial world. A bunch of amateurs quickly took that, butchered it, and pressed it into use for the amateur on bands on reduced bandwidth. The most popular digital SSTV application is written by an Australian, VK4 AES, Eric. The second incarnation of that software is called EasyPower, and it's effectively a digital file transfer program. So it's not just slow scan television, although the most common files transmitted are images. So as I said, generally images, any other file. Uses forward error correction and Reed-Solomon encoding. And I'm not going to go into the details of how all they work, but basically breaking it up, breaking the message up, and taking some of it and putting it into the others so that there is a high level of redundancy in the transmitted file. Because it's a digital mode, it uses a number of subcarriers, 4, 16 or 64 that are each modulated. Obviously the more subcarriers you get, the faster the communication, but the less robust it is. Each of those subcarriers are QAM modulated, or quadrature amplitude modulated. You can have some data loss because you've got the forward error correction. The more error correction you add in, the longer the transmission time. So there's a balance between how much error correction you want, noise on the channel, how many subcarriers. Unfortunately, you either get a full decode or you get no decode at the end of the day, because there is no halfway You either got enough bits of information to get the full image back, or the full file in its basically original form, or you didn't get enough. A bit like digital TV in that way. But the received information is lossless at the end of the day. So the file that you have is identical, bit by bit, to the original file. What does it sound like? Is it going to play up again? I apologise. JT65. Definitely not a conversational mode. 2003, designed for EME work. Dr. Joe, which is K1JT, developed a whole bunch of applications for meteor shower and Earth work. Once they basically worked out they could do Earth, Moon, Earth, a bunch of amateurs said, hey, we can use this for HF communications, and so the range of applications was expanded to suit HF, and it is one of the more popular modes for getting contacts. It's a highly structured, limited structure for the QSO. There's 13 characters on any transmission. Each transmission takes 1 minute. So to actually get the basic QSO, which is call signs, locations, and signal reports, takes 6 to 7 minutes. And you don't even get to swap your names. So it is very, so it's not a conversational mode, unless you're really good at 13 character conversations. The PCs that are used in this mode must be time synced. They must be within sub-second accuracy. So if you're more than a second out, you will not get a decode. So how do you do that? Internet time servers, or if you're, what we're trying to do here this morning when we're setting up is very strategic resetting of the Microsoft clock. But that's very difficult. Most people internet connect, and every 10 minutes update the clock. You'll be surprised how quickly PC's clock drift in terms of sub-second accuracy. As I said, typical QSO is 7 minutes, and in fact that time sync is software called Dimension 4 is probably the easiest one to use, and that software is available here today. Most software, which I'll come to shortly, is available here for people to take with them. I've only got the PC stuff. There are Mac and Linux versions for those that are that way inclined. I just haven't managed to get it all yet. What's interesting is JT65's been around almost a decade now. It continues to be proactively developed with Australian input. Our AEP guys, the Aircraft Enhancement Propagation guys, are now using it on some of the routes, and are actually working with Joe to tweak the protocols. Obviously a 7-minute window is a long one for aircraft enhancement, but they are tweaking it to make aircraft propagation. There's a huge amount of redundancy in the transmissions to make it work. Uses 65 different tones, forward error correction, a lot of error correction in fact. We'll decode at -10 to -14 signal to noise ratio, and actually go down to about -25, and I know people have done it at -27. Pretty much day or night there will be JT65 on the band somewhere. 20 is probably the most popular, 20 meters is the most popular at 14.076. And while we're setting up before the presentation, there was an Argentinian station there. I did this presentation a couple of weeks ago of an evening, and there was UK, Russia, Japan. There was a good spread. France. What's it sound like? Hopefully this works. And it doesn't. No, I'm not. I can play the sound files directly later. Olivia, 2003, just after JT65, and I say, have we come full circle? It's actually, if you look at the time gap between PSK and then Olivia, there's another decade in there, basically. So have we come full circle? It's a RAG2 capable mode. It's there for conversation. It works in the noise. It was developed by SP9 VRC. It has error correction. The first on-air test, again, involved Australians. It was Les to DSG and Fred using the 20-metre band, typical Europe Australian path. There's 40 different modes, and this is where the fun comes. You have number of tones that you can use, 248, 16, 32, 64, all the way up to 256. There's also the bandwidth in which those tones are compressed into, and so you end up with a whole bunch of combinations that way. There are some standard combinations, obviously, otherwise it'd be really confusing to try and use the mode, and they're there, and the most commonly used. Most conversations start on 500/16, and then depending on the conditions, you'll change modes to suit the conversation and the path that you're working. 20 to 40 words a minute. Most hams can type at about that speed. Some a little bit faster, some a little bit slower, but it works for most people. Not quite as fast as RIDI, but it will decode down in that noise at -10, -14 dB signal to noise ratio. You can actually almost get what they call phantom conversations. You can't see the signal in the waterfall, but they will decode on your screen. And that's sort of peculiar for those not used to. You can't actually work out where the signal is to click on it, but they'll be there. And because of that, there are some effectively calling frequencies on the digital modes, so that people can gather in the same place, especially when you can't see the signals on a waterfall. At -14 dB, -16 dB signal noise, it's pretty hard to see it on the waterfall. I'll see if the sound bites work, but I suspect not. No. I'm having a happy PC day. Digital voice, I'm not going to cover digital voice because that's a whole nother presentation, but there is stuff using DRM, same code processors for digital slow scan. There's D-Star, which some love, some hate. AOR had a digital box hardware for HF. Uses the same vocoder. There are some differences between it and D-Star. There's P25, or what's known as Project 25. Actually uses a slightly different codec, but very similar to the D-Star one. But it also appears that we may be seeing some P25 come out in Yaesu's product line this year. So it's starting to gain popularity, shall we say. Codec 2 is another codec that's being developed out of Australia, and we should be seeing some codecs this year, fingers crossed. And it's basically to try and create an open source codec to compete with D-Star. And there's also FD-MDV, just frequency division multiplex digital voice. It's another software based, so PC based, and in fact to do that you need two sound cards. One to go between your mouth and your ear, and one to do the radio interface. And down the bottom there's a P25 radio, there's some D-Star stuff, there's the AOR box and the DV dongle for voice transmission. If you thought that was it, by no means. Right, there are plenty of modes, and it will continue to grow. AmTor. It's funny because I haven't heard a lot of AmTor, but I got an email message last night on a forum that says that the American AmTor operators are getting off 20 meters and they're going to go down to 40 because 20 is too busy. So there's obviously still a lot of, which is amateur teletype over radio. That's what it stands for. SIDOR, there's Pactor 1, 2. Pactor 3 is actually a proprietary codec done only in hardware for sort of things like HF email from Bodies and those sorts of things. CMSK, it was multiple shift keying. It's a protocol developed out of New Zealand and is gaining some popularity. Contestia is a version of Olivia. Sacrifices some of the error correction to get a bit more speed out of it, mainly for contesting. Throb, I've never played with, so I can't comment. Ross was developed out of Europe, has a bit of a law following, but there was some questions about whether it was actually sucking information out of people's PCs and delivering it back to someone over the internet. So you might want to proceed with caution on that one. Unsubstantiated, I'm sure. Clover, another digital mode that has a bit of a cult following, I should probably say, but I haven't played with it. G-Tor, and one I haven't used. There's a whole bunch of multiple frequency shift keying, so using various numbers of frequencies to transmit the data. Then there's a whole series of MTs, multiple tones, so that some of them use the difference, which is actually a highly robust way of transmitting data. So instead of actually having to use frequency accuracy, it actually uses the shift between the various frequencies to transmit the data, and that because that's somewhat independent of the individual tones, it becomes a little bit more robust. Dominex, another contest mode, and then digital ATV, which we see Melbourne and Queensland have done there. A number of their ATV repeaters are now digital, and I believe there's one, Central Coast is now, or in the process of changing over, they're trialling at it. And in the commercial audio world, we have DAB and DAB+, which is the digital audio, and who knows whether they'll make their impact into the amateur modes as well. And basically the sky's not the limit. We've already seen that if you can hit Venus, and who knows where's next, you know. Yeah, there was 9 satellites launched about 3 weeks ago. Most of them had amateur payloads on them. So, and there's a whole bunch that are going to happen in the coming year. Unfortunately, I think we lost 4 on a launch last year, where the spacecraft disintegrated on launch. So there's a lot of money that ended up in the ocean, but yeah, there's a lot of satellites, and I think there's probably 50 odd satellites up there at the moment that have got amateur payloads. 3 are fully functional. A lot of them have been up there from the 70s and 80s, but the stocks are being replenished, shall we say. I've got a couple of charts here. We won't go into too much detail, but there's a bandwidth versus speed. Obviously, everybody's interested in, you know, how much can I get through? How wide is the signal? I didn't prepare these. These were grabbed off somebody off the net. And the too slow was the particular individual saying, I want to be able to have a conversational QSO. I want to be able to operate at, you know, about 30, 40 words a minute. Anything below that's too slow for me. So you can see that some of the PSKs are a bit slow. Some of the Olivias are a bit slow, but Riddy's up there. Riddy 45 is sitting up there. Well, they're saying about 60 words a minute. PSKs, they're saying 45, 50 words a minute. And you see, if you go from PSK 31 to PSK 63, double the speed. But obviously, not as robust. Some sensitivity in terms of noise. Hells, you can see Feldhell is in there. But and this, we can make these slides available to anybody who's interested if they want to go into some of the more detail. Bit of an analysis about weak signal and conditions, and you know, how many errors you get in the transmissions. Where do we play? It's an important thing. So all of the modes, and basically anywhere from 160 and up through 70. 20 meters very popular. 40 is probably next. I was doing a lot of work on JT65, not the Christmas gone, the previous one, and yeah, I worked a lot of stations on 20 meters. And then I decided to move down onto 40. Basically, the same station started popping up, and thought, okay, I've basically saturated the pool here. Moved down onto 40. All the Yanks are sitting down on 40. They don't like playing on 20. So they go sit down on 40. So they open up a whole other group of people to communicate with. What do you need to play? It's probably the important thing. Start answering some of the questions. In the old world, they used to say you needed a rig that could do 1 hertz tuning. I really question that, because that rig doesn't do 1 hertz. That's a FT897. It doesn't do 1 hertz tuning. How accurate do you need to be? Plus or minus 10, 20 is good. Why? Because you can pick that up in the audio, and you can fine tune it there. In the old world, you needed just some interconnecting cables and the TNC, and basically a dumb terminal. What do we do these days? An HF rig, almost anything will do. You have to be able to get an interface between your PC, especially for isolation. You want to be able to not have RF running around, and you want to provide some isolation between your PC and the radio itself, you need a PC with a sound card. So an old laptop would generally do it, or an old desktop. Software generally is free on the internet, and as I said, there's a heap of it here today to give away. I think the important thing is you need a standard and advanced license. They're digital modes, they're computer controlled, so you need at least a standard license.